At the end of the day, your data provider, their incentives are completely opposite to yours. You're trying to do something the fastest and the cheapest, and they're trying to charge you as much money as possible because that's how they bring in revenue. And like, yeah, we want DBT to continue, but we also want to know how to optimize our queries on DBT. So just remember that understanding the tools around your SQL, again, the systems around your SQL, is going to be the most important thing for leveling up your SQL skills. Hey, everybody. Welcome back to Saturdata, the podcast where we teach as much as we learn. How are you doing today, Sam?
Feeling good. I don't know if you can see my Sasquatch with the red solo cup on it. So I'm ready for Christmas.
Yes, a classic Christmas symbol. Sasquatch is coming to town. We're filming this during the holidays, and it's a really nice time to just chill and focus on Saturdata and the other things that are, foremost in our lives. And today, I think we're talking about the core of the data world, the skill that data analysts, data scientists, and data engineers have in common. So wherever you are on the data spectrum, this one is for you. Sam, what are we talking about today?
Squeal.
Squeal, yes. We're talking about SQL. And if you say SQL, which apparently I did last episode, if you say SQL, I'm going to assume that you either are a software engineer that doesn't actually do data work and you just use a database in your Express app or whatever. And if you say Squeal, then I think you might have seen the same internet meme that I did, but nobody says that. I think it would make meetings more fun if we're just squealing. Yeah, if we just say, I coded this in.
Oh, you actually just make a squealing noise?
Yeah, you actually just squeal, and then people can figure it out.
But I forgot something. How are you doing?
Thanks for asking. I'm doing really well. I have some family coming in for the holidays, which should be really nice. And something I'm really looking forward to is there's a Jewish tradition of going to get Chinese food on Christmas Eve. And so there's actually a Jewish comedy show at a Chinese restaurant on Christmas Eve that I'm going to go to, which I think is really funny. So we'll see how that goes.
I think that's like a really fun collision of worlds all happening in one place.
Yeah, it's just like we're all off, but we don't have anything to really do. So might as well come together, meet people, have a nice time. The Chinese food place also has 2 stars on Google. So I don't know if the food will be edible, but it'll be funny either way.
Now I want Chinese food. I want to convince my wife to go get some Chinese food after this.
Yeah, totally. After we wrap up and teach everyone, 5 years worth of SQL in however many minutes.
Yeah, sometimes we plan for 25. Sometimes it turns out to be 45 or 50, and then we have to break them into multiple episodes. Sometimes, who knows? Who knows how this is going to go? But we have a lot to talk about, so I guess we should get into it.
Yeah, we can get into it. And I think the first thing we wanted to share with people is there are different levels of SQL, and you can kind of tell exactly what level someone's at based on how they work and how they talk about their work and the things that they're kind of focused on. So what do those different levels look like for you?
So for me, I break SQL into, we all do threes. Everyone loves 3. It's a good rule of 3. Data warehouses does 3. So everything's a 3. So basic, intermediate, and advanced. Basic can be anywhere from, I'm taking a Udemy course or a data camp course about SQL to I'm using it in one of my undergrad or graduate level courses to I just started a new job, and in this job, they have me using this thing called SQL, right? This is basic stuff. So it's learning the order of, not even the order of operations, honestly. It's learning the vocabulary and the words and what is SQL used for and why would you use it? And I think that's the beginning level of SQL. Now we have intermediate. So intermediate level is, okay, you graduated beyond your basics, you passed your basic training, you moved on, and you now know what to use SQL for. You now know what SQL can do. You were writing code and, some SQL code, if you even could call SQL code, but you were writing some SQL statements, you were getting answers. You maybe needed to pass that query off onto someone else to say, is this right? Did I even do this right? Does this look like the right thing? Now in your intermediate stage, you've kind of moved on to, I'm doing it right. I'm 90% sure I'm doing it right. I might still ask questions here or there, but really at this point, it's I can hear something and I can almost start envisioning the SQL in my head about how I would go solve the problem that someone's talking to me about when I really should probably just be listening to the problem they're having, because then I'm missing out important details because I'm trying to picture the code in my head, but that's a whole different topic we can talk about later. But you start being able to see in your head, I'm not saying you get there all the way, but you can start to make sense of it. Now you're using less maybe like distinct star and some other things we'll get into. Maybe you're starting to understand that some queries run faster than others, and you're starting to maybe understand why some queries are running faster than others, and starting to be able to write your queries a little bit more efficiently, also depending on the system that you're working in. And then that's where we start moving into, right, the advanced. And the advanced for me is when, you hear something, you can pretty much right off the bat start writing the SQL. This is when we start talking about the idea of recursion in SQL, which I don't do a lot of, but every now and again you might run into like this recursive problem. The classic recursion problem is like trying to find the hierarchy of managers and individuals to their managers in a company. It's like that's the classic, I think, recursion problem in SQL. You start understanding all your different window functions, like group by cube and group by rollup, and like the different group by commands that you could run. And there gets a lot more specific into some of the efficiencies of the different commands. But now you've moved beyond that too, and you've now moved into, right, why am I running the SQL? Right. It's actually even asking the question of like, instead of just taking orders, you're now like, could we do it like this? Because you now know maybe the limitations of the data you're working with, the limitations of the system you're working with. So you maybe start having better ideas. So you almost even notice like a progression with your SQL skills as a progression with your own career, that you're getting better at the SQL that you're writing, but you're also getting better at asking the right questions to write better SQL based on the information that you have when you start writing the code, right? And then also the systems that you're using, like we said last week on the episode, right? Tying those things together, getting them to flow through, and not just writing code, but actually writing code as part of a larger system, as part of a larger thing that you then need to tie together with your auxiliary data skills that we talked about last week. So that's my 20,000 long minute overview of the three levels of SQL. Would you add or change anything about that?
I think that was great. And we'll add so much onto this when we talk a little bit later about like what are the aspects of SQL skills that you don't actually learn in school and you learn from the business that you're working in. But the one thing I would add now is kind of an example of how that advanced SQL skill set fits in with the auxiliary data skills that we discussed last time, and a story that I actually shared with you earlier. But there was a situation where my team had miscalculated the cost of our data sources, and we essentially needed to be paying $750,000 a month, or $750,000 a quarter rather, because we were using data from a specific, very expensive data source, and people were not tracking that properly, because the way that this was being tracked, unfortunately, was a manual Excel worksheet where people were manually adding up numbers and just writing them down with no like tying to another source, or no real documentation. So it was kind of like a just trust me, bro type of system. And we know that doesn't work great in production, in budgets, and when clients are depending on you, it's not ideal. So when this landed in my lap, I first manually calculated this number, and I said, hey, this is 750K more than we think it is, and we need to address this right now. And I realized that this is going to keep popping up if we continue this system. And not only that, but we need a way to audit this that isn't manual, because honestly, if something's manual, nobody's going to do it. So what I came up with was really just a simple SQL query. It had a couple joins and some filtering that was going to say, okay, based on your analysis, which data sources are you using? Okay, once we have that list, let's join to our pricing table that tells us, each data source mapped to its cost. And then you can scale that up to however many records or however many times you're calling that data source. And from there, you have the cost of the data analysis project that you're doing. And this is something that we probably should have had from day one. But it wouldn't be that useful as a plain SQL query. I could have shared that around my team and had people copy it. But what I did instead was I went to our shared code repository. I created a command line tool where all you have to do is like submit some command line arguments and then have that output tell you the price of your data analysis project for you. And when you can combine the terminal skills, the SQL skills, and just like the business understanding of like, how am I going to make this accessible? What types of tools is my team using? That is, I think, more of an advanced use case where SQL is the means to the end.
Like advanced SQL is almost not even SQL. It's like
Yeah.
Intermediate SQL combined with a bunch of other things that get you to the thing you need to get to.
Yeah, 100%. I think like the majority of people are not using like stored procedures, which is basically building like programming functionality in SQL. Like any sane person, you're going to build imperative functionality in Python, and you're going to use SQL as a declarative query language that it is. And the way that you'll get more advanced is exactly what we said last time about building those skills around SQL, knowing how to pipe SQL output through a bunch of different tools. And now you have something really useful that's more than like SQL in your IDE can give you.
Yeah, and we're making certain assumptions about the tool set that you're working with underneath this, right? Too, when we talk about this, because we're also making assumptions that you're not like locked into SSIS and like you can use Python, you can use Bash, you can use some of these other things that we talked about last week too, right? To wrap around the SQL that you're working with. Now, if you're just like locked into SSIS, well, then that's a whole different problem. And this episode's not for you, or having a conversation with me is also not for you because I'm not jealous. But exactly, yeah, it's more about how does all this tooling fit together. And I guess my example of like advanced SQL help kind of that I wanted to give in this part of the episode too was one of my first jobs. I was a data scientist at a pest control company called Terminix. So I had a lot of fun there, grew a lot there. But one of the biggest projects I worked on was something where we were overstating revenue, and that came from a consulting firm that had come into the company, and they had written out this like 1,400 line long SQL query that had a bunch. I mean, obviously it was just all CTEs and subqueries, but at the end of the day, this SQL query then just wrote to a table. Like 1,400 lines of code wrote to a single table. At the end, there was no transient table, there was no temporary table materializations happening in there. It was one table filled with a bunch of subqueries and CTEs. So obviously debugging that was a nightmare, and ended up finding like millions of dollars of overstated revenue coming from one of our like predictive models, or the predictive model they built in this 1,400 lines of code. So it was like a very rough predictive model, right? Trying to understand like how much LTV per customer, so lifetime value per customer, would we realize over 1 to all the way up to 10 years. In the SQL query, there were like some fundamental errors that were made that caused us to be, and these were numbers that were getting like reported out to like the chief revenue officer and other like really important people in the finance sector that were like, we expect this amount of LTV should, nothing big change over the next 5-10 years based on these individual calculations, but the individual calculations were all wrong because of some fundamental assumptions that were made that were incorrect. And like debugging that was a nightmare, and it took me probably a month because of how monolithic the system was, right? And so there was
Yeah.
a part of that was me knowing SQL that could allow me to pick that apart and work through it, and there's a part of me that knows other things and knows that if I were the one to have written that query, I would not have written it in one table for 1,400 lines of code, right? It would have been split out across multiple tables. There would have been materializations happening at different steps. Maybe we're now thinking about using DBT, and trying to test our code even, and all is just so many learnings came through that one exercise, right? That were really interesting to go through.
Yeah, I think there's so much in there and such a good example of how advanced SQL is about practices that you're applying almost outside of SQL. And the things that stick out to me that I would want to highlight is bringing these engineering best practices to your SQL processes. And like, how would you know, Sam, that this query is now in a good state? You would know that because there's four main things that are happening in your rewrite of this process. Number one, it's going to be more readable. You're not going to be looking at a monolithic file that's 1,400 lines of code that is just like leaves your brain swimming and not knowing where to look. The next thing is maintainable, where if you're debugging or you're needing to fix or change this process, it's easy to change. And that goes with the readability and the distributed nature of how you fix this problem. The other things would be observability and explainability. And these are really big in machine learning too. So people in the machine learning world know about this more than others. But essentially what it means is observability. Can I see what's going on? And if all you have is 1,400 lines with one output table, you don't know, like if you're debugging, which transformation is the problem. And do you have any breakpoints? Do you have any like intermediate tables to show you what's going on? And then the last one was explainability of like, if someone asks you how you got this number, pointing them at this file is no good, especially if it's a business stakeholder. And so you need to have documentation, you need to have testing, you need to have all these things around it. And even if you think about like the engineering review process, people will post on your pull request on GitHub, like, why did you do this? And usually in the data world, there's none of this process. It's just like, oh, we have this code that does it and we don't question it because it works. And that was where we stopped. And so I think like data scientists really deserve this rigor that engineers are accustomed to. And it's those four things, the readability, maintainability, observability, and explainability, that we want to bring to all of these SQL processes here.
That was a lot of abilities, a lot of
Yes.
ilities.
Make your SQL more able.
But I like the four groups, and thinking about it in the four groups. And that's where tools like dbt, right, I think really come in and help people do a lot of that.
Yeah, I think that was why I love dbt so much. The first time I played with it was just like, oh, it's giving me all the stuff that I want my company to do for me, and it's giving me that infrastructure, and I don't have to set it up. All I have to remember is like dbt run, dbt test, more commands for the terminal folks.
As you can tell here, we're really big on terminal and short, sweet commands that do a lot of things for us. And dbt has a lot of that, like explainability, because you have testing, right? And you could say like, we pass these tests. You could say observability because it offers something like lineage, right? Column table lineage, so that it fits into a lot of those ilities as well.
Yeah, you had something in our plan for today called worm that I actually have never talked about. Can you tell us a little bit about worm and write once, read once, WARO, and tell us how that connects to SQL?
I don't actually know if WARO is a term, but I'm pretty sure worm is a term. WARO I might have just made up, but worm is definitely a term I've been exposed to before. Like language in general is just a bunch of sounds that we agreed mean something, but I guess that's a different conversation for a different time.
Mm-hmm.
Right. So this example that I'm bringing in is something an activity I try to take on now with my clients at work is, do you want to take on, it's like a very specific SQL thing, but do you want to take on the cost at write time, or do you want to take on the cost at read time? And the answer to that depends on how you're going to use the data in the table, right? You're going to write the data out one time to that table, and then you're going to read it out one time because it's just for this ad hoc activity. Then there's a lot of things we could talk about, right? Optimization, probably not that important. You don't really need to incur the cost at write time because you can just incur it at read time if that makes things easier for you. And by that, I mean like, you don't need to you don't need to cluster, because if you run a group by later, you could just incur the cost at the group by time whenever you're running that query instead of trying to like sort and cluster beforehand, right? And that's specifically in the context of like an order by statement. So I think we're in advanced SQL like right now in this part of the conversation. But if you're going to write once, read many, worm, if you're going to read many times off of something that you only wrote once, then you want to incur any cost that you can at write time, because then all your read operations will benefit from the one time you wrote and took on the extra time, took on the extra money, the compute cost, whatever that is, to write out to the table in a way that's efficient and optimized for downstream processes that now pull from this table. Keyword there being processes, not process, right? Because then there's many things that will benefit from the write. Whereas, our WARO is a write once, read once. So again, I think it's a made up term, but it helps you like rationalize how much time you want to spend. Do you take the square peg and force it into the round hole, which is WARO, or do you take the square peg and chisel it, turn it into a round peg, and then put it in the round hole? And I would call that worm. Like you took the time to make sure it fit, and then you put it in the right place. And then everything after that is going to benefit from the time that you took to do the work up front.
That was beautifully said. And I think what this speaks to is another area of advanced SQL work, which is again, thinking about SQL in a different way. And so ever since I read the book, Designing Data Intensive Applications, which I highly recommend, especially for data engineers, but also just people who want to understand more about how to design SQL processes within bigger systems, is kind of using SQL as an analyst versus using SQL as an architect. And they're both valuable, but I feel like using SQL as an analyst is just the tip of the iceberg. Because when you think about like, how am I designing this table based on the use cases? Should I be designing it for heavier writes or heavier reads? And how does that change the data types that I use? How does that change the joins and indexes that I'm going to use? Like, those are really interesting questions that show me that you are a deep, advanced SQL user, database admin, data engineer, and really systems designer at that point. And so I think those are like, if we had basic, intermediate, and advanced, this is like a secret fourth level that you can only unlock once you understand what's going on under the hood here.
You have to have like, you can say it and you can read it in all the books you want to read it, like even Designing Data Intensive Applications, which I haven't read, but it's on my bookshelf over there. I'm looking at it right now and I'm scared by it. So I definitely need to pick it up and read it. But yeah, I mean, even reading the book, any book, it's still not going to come as naturally as like having gone through it, having fallen on your face and then realizing it later, like, oh, I should have asked the right questions about this scenario. So I think that's maybe just like a shout out to anyone that's like at a beginner level in doing the readings and still feeling like it's not clicking quite yet. And it doesn't click quite yet. I think I had this problem a lot earlier on in my career because you just need more time. And that's where we get into like years of experience and job requirements, which I think are silly. But at the same time, there is some element of it that is beneficial, which is no matter how much preparation you have, sometimes the real thing is a lot different than all the prep work you put into it.
Yeah, there's no substitute for experience, which is why we emphasize building your own projects with minimal AI involvement, which is why we emphasize that so much because you are solving the problems, you are hitting the errors. And like that's the benefit of experience is when your brain is working on something in deep work for a long period of time. So you have time to synthesize these concepts and like imprint them in your brain because it's not just something that you're reading, it's something that you're doing and having to arrive at. Like the difference between school and the real world, which we'll get into more in a minute, is in school, they say, here's a concept. Now go use it. And in the real world, it's here's a problem. You can use anything you need to solve it.
Yeah.
But you need to
Yeah.
now go see what are the solution options? What's the best one for my use case, my company, and my tool set? And then apply that. And for me, that is what makes things stick so much stronger.
Because it's December, I just went through Advent of Code and
Yeah.
I made it to like day 10 out of day 12, so I didn't quite finish. But I was doing it in Rust, which I'm apparently masochist. And yeah, that's just like the same thing for Advent of Code. It'll give you like a word problem and then just expect you to know behind that word problem there's like a graph algorithm. So I won't spend too long on that, but like that is the real world. It's like you get a word problem and you have to know like what methods to use to solve that word problem. It's not just like school. And I think that gets us into our next like subsection here is what we've been talking about the last 5 minutes probably is it's not just the query that matters, it's everything around the query, right? So we hit a little bit on DBT with like production level SQL. Something else they want to hit on a little bit too is platforms and platform dependent code. So we think about how something like in Snowflake, columnar store, distributed compute, right? There's going to be a lot of different things that you can do in Snowflake that you might not be able to do on an on-prem system. But at the same time, again, we're at an advanced level here. Is that good or not? Like, do you want that code? Do you want to be able to get up and go get a coffee and come back and then your query is like about to finish as you come back from your cup of coffee? Like that's probably on-prem. It's probably fine.
Mhm.
Snowflake, probably not, because you're paying for your compute. And did you really need to wait all that time for your query to finish? Can you optimize it? Is it as optimized as it can be? Right? Because the less optimized your query is in a cloud platform like Snowflake, the more money you're spending. Right? Whereas on-prem, that's not the case. On-prem, it can run for 24 hours. It doesn't matter. Like you're paying for what the energy used by the server sitting on the rack, like it's not that large of a cost compared to the Snowflake compute that you're paying for at the time. So if your code changes based on the platform that you're working in, SQL Server, Oracle, Exadata, things like that are going to work differently than our Snowflake tool is.
Yeah, and this is another time to, I think, bring up a technique that intermediate to advanced SQL users will never run a query on the first attempt on an entire data set. So like if your data set is partitioned on date and category, for example, then an advanced engineer who wants to build a solution will say, okay, I'm going to filter on, date equals 2025 0101, category equals category A, limit 5, and then see, okay, does the output shape look like the shape of the data that I'm looking for? And only after you've done like a bunch of little testing on tiny slivers of data will you ever run an expensive query on billions of rows in Snowflake or even on-prem. Just because like, someone else's query could be more important than yours, that they need that processing power at the moment. So whether the cost is like just taking up more memory or the cost is physical Snowflake credits that you're paying for in a distributed system, you should always be testing on really tiny amounts of data. And we'll get into exactly how you figure out how to do that in a bit, but I thought that was a good thing to call out.
Shout out to my BigQuery and Athena users who get charged based on data scanned. So watch out for that. when you run a limit command, like you said, you need to put the where filter with the date and a limit command, because if you just put the limit command, you're going to scan your entire table and you're going to get charged for scanning that entire table. BigQuery and Athena are a little sneaky about that, where you could put the limit 5 in, you get 5 rows back, but you just paid $10 for those 5 rows. Heads up on that.
Yeah. And this is like, at the end of the day, your data provider, their incentives are completely opposite to yours. You were trying to do something the fastest and the cheapest, and they're trying to charge you as much money as possible because that's how they bring in revenue. And like, yeah, we want DBT to continue, but we also want to know how to optimize our queries on DBT. So just remember that understanding the tools around your SQL, again, the systems around your SQL, is going to be the most important thing for leveling up your SQL skills.
That's true. All of them are SaaS providers, right? So they all make money based on consumption, right? So that's just the one thing to keep in mind. The next thing we have is what they don't teach you in school, right? And it's kind of falling into the section of it's not just the query, right? So there's a lot of things once we move on past the query, even past production level SQL, even past the different platforms that we could be using. There's all these different like Easter eggs, we might call them, about things that we've learned or things that we do at work, which we weren't taught in school, and kind of have just come from the battle scars. And we've already talked about some of those things, but what are some of the other ones that we were thinking about?
Yeah, I want to talk about things that go hand in hand with what we were just discussing, which is, okay, if you want to test something and look at the output without running a scan on billions of rows of data, then you're going to need to partition on the partition column. So you're going to filter on that partition column and add a limit. And what does this mean? This means you know the columns that are in the table. You have some sense of the cardinality, the number of columns in your table. You know what the rows are telling you, and you know exactly where to look. And so what I would consider this skill to be is I'm going to call this data fluency. And this is the most important skill for data analysts, 100%, like no question. And what this means is when a stakeholder says something in the meeting, you know exactly where to look. You already have in your mind, like Sam was saying, you have in mind, okay, these are the tables that they're concerned with. This is the query. This is the type of filter I need to do based on how the data is partitioned so I can get it efficiently and quickly for them. And when you build this skill, this is what makes your stakeholders trust you because they can see it in your eyes and they can see it in your body language and your presence in the meeting that you know where to look and they can trust that you're going to get this answer for them. And this is where they feel comfortable saying, oh, yeah, this data analyst, they can handle it. They got it. And I think it's such an important skill, both technically and also to build trust.
It's like a soft skill. Yeah, just knowing if you're the data guy or data person, just be the data person. Like, just do that. That's your job. So do that
No,
part
but
of
then
it.
it's also technical. It's also technical though, because you need to know how to write efficient queries because you know the data like the back of your hand.
Absolutely.
That's what I was trying
Exactly.
to say.
Like being the data person is all encompassing. Like it's having the knowledge of what data you have and then also what you can do with the data that you have. So that's where the technical skills come in.
Yeah, no, exactly. And this is why, again, documentation is super important. So platforms like DBT build this in, but like, know who is the owner of this data table. So you can ask them questions and like, what does the star schema look like? And which tables are flowing into it, which tables are flowing out of it, and just all this stuff is super, super important. And that could bring us to the next kind of parts of what they don't teach you in school is like, Sam brought this up with me earlier that sometimes people don't know what their data table is for. They just hand you a table and say, hey, I need you to like make magic out of this. And this brings me back to my biggest gripe with like people thinking that the data world is magic. No, it's not. But people don't even know what their table is about, what its purpose is, and what it means. So like another really important thing you need to know in any data role is you need to know what this table is for, what purposes does it serve, what decisions does it support, and who's using it. And then from there, is the table actually worth maintaining? Because if nobody's touched this table in 3 years, it's just sitting there taking up storage and cost, then now you get to be a hero and you get to say, hey, I think we can clean up this table or we can consolidate it with this other one. And now we're saving 50% on cost. And now you get promoted because you took 2 seconds of your life to look at this table.
Audit patterns are huge with data swamps. They can turn a data swamp into a data lake if you have efficient audit patterns or if you create efficient audit patterns where there are none.
What's an example of an audit pattern that helps people save money?
What you just gave was a great one. So I do currently work at Snowflake, and a lot of the things I do with my clients are like health reviews and account reviews for them. Just kind of periodically, I'll check in, maybe every 4 to 8 weeks, somewhere in there, and I'll check in like, hey, here's how things are going. And sometimes I get pulled in to do ones for other customers too. And one of the lowest hanging fruits for those reviews is, hey, you have most recent one was 10 terabytes of active storage on tables that haven't been accessed in over 365 days. Like daily active storage over 10 terabytes. Okay, it's not a huge amount when you think about Snowflake pricing. I think Snowflake is 20 or 23 or something per terabyte for storage. So if it's 20 times 10, that's $200 a month multiplied out the $1,400 a year or 60. I can't even do math. $2,400 a year, right? So, it's not maybe not a huge cost savings, but if you can free up people from having to look at those tables while they're scrolling, having to think about that table even being there, even though no one's accessed it, like they might still see it while they're scrolling. Like, I don't know, these little like micro benefits of just freeing up mind space for a lot of people. And maybe even some people are worrying about like, hey, I know that table's there. I never use it. I wonder if anyone else ever uses it. Like if you just go through these like little
Yeah.
audit things that could be really beneficial for your organization from a cost perspective, sure. But there's a lot of other ways where you can kind of free up mental noise for your developers, I think, too.
Yeah. So almost having this like rule based alert that you can either programmatically set up or just like know what to look for is really powerful. Cool. And so assuming that you've audited your table, you've looked at this table, you know what it's talking about, you know what's in it, you know who's using it, you determine, yeah, we should keep this one. From there, you can move on to the row level. And this is what we call granularity. And so the question that we're asking here is like, what does each row of this table actually represent? And I'm forever, forever grateful to my first ever data manager, Constant Dugas, now a data scientist at Spotify, I believe, where every single time we spoke during my internship, he would say, okay, what is this row of this table you produced? What does each row mean? And if you can't answer that question, you don't know what's going on. So think about like if you're analyzing consumer patterns, okay, is each row in order? Is each row an item? Is each row a customer? And these things become so important because if you're building a dashboard of like, stakeholders need to know how many new customers did we acquire this week or how much revenue did we get this week, then you need to know, are there going to be duplicate items that belong to the same order? Are there going to be duplicate orders that belong to the same customers? What's the primary key? And like, if you want to be able to answer these questions really quickly, your data needs to be modeled in a way that you can understand it easily and other people can too. So yeah, knowing what each row represents is a big deal.
I was about to say what you just brought up the modeling word. Like this is where fact and dimension tables really help because then if you're using a table, it's labeled as a dim table, you can make some assumptions about the granularity of the table that the things in
Mhm.
there are, slow changing. If we want to talk about SED type 2, it's it's an address, it's a person's name, and then you can not make assumptions, but you can just infer what it is faster. You dive in, you see, you confirm, and you move on. Like it doesn't take you as long. Yeah. And then the fact table is okay, I know I have a lot of data coming through this fact table. This is a big table, it's continuing to grow, it's got order information, it's got order item level information where it's not only the order but it's also each item in the order, and you might have different tables for those. So yeah, it just helps you reason about the things faster and know that, okay, once I join this table to this table, I'm going to get this, right? And then you can work with it from there, but you have to know at each step of the transformation, yeah, like what a row means. And I think that's really basic, but something that they never talk about in school, right? We never learned about that.
Yeah, 100%. And then I think the last thing was something we definitely did touch on already, which is based on your systems around your SQL, just understanding the cost of large joins and the cost of a select star, as opposed to selecting, column one, column two, column three, which again comes back to data fluency, knowing your data. You shouldn't have to guess what's in your data. And when you're working at scale and you're paying many dollars for every Snowflake credit, optimizing your join is not optional, it's required. So like you should absolutely be eliminating as many left joins as possible. You should be using group by instead of distinct. And you should know these things again, like the back of your hand, and know how to cut down that cost before you even start writing your query. Is there anything else you want to say on that?
Never run a select star in a production pipeline or a pipeline that's designed to go to production. If the upstream table changes, you need to know. So sure, writing out your columns is probably going to break your pipeline, but you'd rather build in kind of the ways to handle something like that happening, to communicate better with your upstream team, or just handle that break in a way that your team determines you need to handle that break, versus
Mhm.
a select star, which is just going to pull your whole table in. So if they keep adding columns, you're never going to know. And then you're just going to spend more and more and more on the storage and on this actual query because you're pulling in more data that, because it wasn't there in the first place, you probably don't need it now. So
Yeah.
why are you gonna pull that data in?
Yeah, it's almost a data quality check at that point of like, are these the columns that I'm expecting? And I would rather my pipeline break and I fix it versus like 3 months later, someone says, hey, why did this cost balloon? And then I now have to look through a silent cost factor like a select star and find
Yeah,
that even though
I don't know how
I've
to
never been
trace
able to
that
find it.
back. Yeah.
Yeah.
I know this query was more expensive for some reason, but why? And it's
Yeah.
the select star.
Yeah. And so a beginner SQL user doesn't even know to look for that. And an advanced SQL user sees that coming a mile away. and says no select star in any pipeline ever.
But
So
we
yeah,
have
that's
but we have
another good
infinite
one.
but we have infinite budget, right?
I would
Right.
say if you're exploratory querying, you can pretty much think of it as having infinite budget. In production, you never have infinite budget. Yeah, but don't get so bogged down that you spend like 20 minutes calculating the cost of an exploratory query. Just use the rule of thumb of like partition your data at a limit. There's a balance of this. Like you don't need to have a panic attack about cost every minute of the day, but you should panic a little bit about cost probably. It's probably a healthy
There
amount of
should be
panic.
like a productive anxiety around it. Yes, but
Yes.
not like debilitating.
Yeah. No, absolutely. Damn, why does all this matter?
It's a great question. I was going to ask you the same thing. No, I'm just kidding. So one of my biggest things I think earlier on in my career that I've run into less now, maybe it's because I've grown, the industry's grown, I don't know what it is, but a lot of times companies will present a financial report, but there will be like asterisks and there will be like footnotes and assumptions listed because something about the data they need to CYA, right? And they need to be like, well, if it's not right, like there's XYZ reasons why it wouldn't be right in case we get audited and it turns out the numbers don't match, right? And there's like so many legal departments and other departments that are going to help you with the CYA element, but all of that kind of comes back to like questionable data, right? Whereas even like the data people are like, yeah, we presented that, but we're not even sure if like that number is right. Like we cannot even guarantee that that number was the right number to put on that paper, but they asked us for a number, so we had to put out that paper. And so that can be because of, again, questionable data coming from the source. It could also be because of loose joins, poorly thought of queries that don't catch edge cases, or just bad SQL. And so there comes a lot of times when we need to be responsible stewards of data and of the code and the SQL that we're writing to make sure that those types of issues, right, we catch, we're on top of. And like you talked about earlier, one of the ways to do that is the different ilities, the observability, the explainability, the debuggability, I don't know, the other ilities that you included in our 4 pillars.
Yeah. I feel like I could even write a mini book on that. I feel like we have something there.
I think we do, and we can go around collecting horror stories.
Yeah, we honestly could. We could do like a spooky data horror stories for Halloween. It's a long way away, but yeah. And I think what this is all coming to is that people are just trusting that you are doing all these things. A lot of times, like it's not systemic the way it is in engineering teams. And you just need to be self-validating, ready to explain, ready to debug, ready to justify any decision you make. And something that I always come back to that Tina Wong, one of the most popular data creators, has shared is that you are a lawyer defending your query, your machine learning model, et cetera. And you have to be ready to mount a case because the second you come into that stakeholder meeting room, they will ask you, how'd you get to this number? And you have to explain it in terms they can understand, in terms that tie with finance, terms that tie with product and all the other teams that are not, maybe they're using Excel and they're not using the tools that you're using. But you still all need to have the same process in English or whatever language you're using at work. So I think when you can do that really well, you are more of an advanced SQL user because you're bringing it into something real.
Because it's beyond just the code at this point. Yeah, it's getting the buy-in from the other teams and the trust from the other teams that you can answer any question they ask you about the data and about the numbers that you've presented because you went through and did this activity. So as long as you did it and AI didn't do it, right, you should be able to have the answers to these questions.
So like if a non-technical stakeholder comes to you and says, hey, how do you know that when you're combining all this data, you're making sure that you're not getting any duplicates in there? And you know in your head, I made sure to use a union. I made sure not to use union all because union all keeps duplicates and union doesn't. What you'll say to them is the code that I used deduplicates for us at the end of the process to make sure that even if there's an error some of the way through, we're going to fix that at the end and ensure it doesn't hit our end users. And so being able to know what you did, make a intentional choice and then defend that choice, that is the real skill here.
Assuming that when they say duplicate is the entire row and not like a composite key of multiple columns or the primary key, because then we're talking about like a rank or a dense rank in order to make sure we're only pulling one of the right ID. But even within that, right, even within deduping, we have to interpret what someone says to us, and it's like, did you dedupe? And it's like, well, what do I think they're trying to tell me right now? And sometimes you have to ask clarifying questions of that, and sometimes just based on context, like what they're asking. Like your manager might be like, did you dedupe? And he just means like, did you dedupe on the primary key or did you dedupe on like whatever these rows mean, right? And another important place where it's important to know what the rows mean. Or if someone else from another team's like, did you dedupe? Maybe they're asking, did you dedupe the entire rows? And I just know there's no true duplicates, but they don't actually know how the data is structured, right? So they don't know that really I needed to dedupe on the primary key, not on the whole row. So it's like, yeah, even within that, there's many directions we could go. And based on the person asking, we can ask for more context, or we can just give the answer based on what we know the answer needs to be, if we know what the answer needs to be there.
Totally, totally. And you're right. Yeah, even there, I should have asked more questions, assumptions, make an ass out of you and me or whatever. And I
No,
think
but
I
not
think
even
one of
that.
the
I think I'm just trying to pick out like it can be so very situation specific. Which one, when we say dedupe, is like the right way to go? Because even I can take for granted like the word dedupe. I'm like, yeah, sure, like distinct, whatever. But maybe that's not like the right dedupe.
Yeah, and I would so often at the top of like an output Excel spreadsheet, I would write like, I'm assuming that when you asked me X, Y, and Z, this is what you actually meant. This is what I
Eh,
did. These are the categories that I filtered on. And so like there would be no questions, like no room for questions. The only
yeah,
thing that they could come back with and say like, hey, I actually meant Z, so go do it again and change this one line. And like basically just making it impossible to have assumptions that are incorrect. And one of the most powerful things that I've learned in recent years to do that, both like at work and also in personal relationships, is the skill of mirroring. And I think it's so important for technical communication and also just like psychologically in general. And mirroring is literally just me saying like, okay, here's what I heard. I'm going to say it back to you. Make sure that I got everything and I'm not missing anything. And this is such a great way to make sure that if you're going to spend the next sprint on a project, make sure it's the right project and make sure that you're doing the right thing and you're not missing a single detail that's important. And if you're just talking to your friend and you want them to feel heard, just say like, "Hey, I'm hearing you say this. Is there anything that I'm missing? Because I want to make sure I fully hear what you're saying." And so like this is going to save you a lot of time if you want like a foolproof dumb way to make sure you got all the important bits.
repeating things back to people is big in consulting too. We do this a lot where it's I hear you say something and I'm going to repeat it
Mhm.
back to you in a way that sits well with me and I can understand it. And then, right, we'll make sure that we're both on the same page, or at least like putting what you said into my own words and making sure that I still understand what you said.
Totally. So I think we've talked a lot about different levels of SQL, the things that
Yeah,
people are missing when they're in school, and ways to kind of level up. What do you think are some of the things that are holding people back from improving in their SQL?
exactly. So I think here it's important to understand again, the system you're working in a lot of times has certain limitations. And my assumption that I'm making here is cloud, right? I'm working in the cloud. I'm not referring when we talk a lot about this, we're not talking about on-prem systems unless we might specifically state it. So some of these concepts, right? Select star, we've talked about. I say subqueries are inferior to CTEs. I think most people, or common table expression CTEs, I think most people would back me up on that.
Hmm.
There might be times when subqueries are fine, and there's a reason for that. I want to go through and we can like pick on the different examples, right? Select distincts. So anytime we're running a distinct, it's like a really highly inefficient operation. If you want to dedupe, if you want to do a true dedupe, distinct would work. But again, how often do you really need to do a true dedupe of all the rows? You could probably more efficiently pick one, two, or three columns and run a dense rank, a row number, a rank operation over them. Because distincts, they have this really terrible thing about them where imagine if you have workers that could be, you could parallelize your data over these 20 different workers and run this one operation. When you run the distinct, it passes all your data through one of the workers because it needs to know that this is a global unique value, like a globally unique row, right? And so in order to do that, there's only one worker that can filter through all of the rows because the one worker has the knowledge of all of the rows. So that's essentially how it's working. So select distincts are not parallelized at all. But if you do something like row number, and if you combine row number with that row number being on your partition column, then that's a lot better, right? I can give different instructions and send those off to different workers, and I can then pull later. I can run the qualify to pull off just the one, the two, the three, however many rows I need from that, and then qualify specifically is a cloud command that again not going to work in NC SQL, but works in Snowflake. I'm pretty sure also works in a couple of the other cloud providers like Databricks, being one of them, where you can run a qualify instead of having to write a CTE. Because oftentimes when you write the row the row number, the rank, the dense rank, you have to put it inside of a CTE, and then in the next statement, filter out based on which of the rows you want. Whereas with the qualify statement, you can just put all of that into one SQL query, and that's pretty helpful too. But that gets a lot on kind of the distinct and some of the drawbacks from using a distinct. So try not to use those too much. And then, like I talked about earlier, trying to force everything into one script and one query with that 1400 line monolith, break things up, right? Modularize things. We're not software engineers, but we can definitely pull from some software engineering best practices, like you talked about, and modularize our code.
Yeah, and I want to add on one thing to that. I think that was all great. On the topic of distinct and why distinct is bad, understanding which things are not parallelizable is crucial to working in a distributed data system, which you probably will if you're on a modern data stack. And unless everything is on-prem, meaning that it's your company's data center, servers, et cetera, that they own, you're going to be working in the cloud. And so the other operation to have the same caution that you hold with distinct, you should also hold for order by. Because what happens is what we call a shuffle in like the data engineering framework. And this is something Zach Wilson talks a lot about. For those who follow him, definitely check out his content on this, where again, you have this bottleneck on a single node of your system, where when you're ordering, everything has to be in sequential order. And that can only happen on one worker node. You can't order things in a distributed way. So when you understand you can't select distinct in a distributed way, you can't order it in a distributed way, then you can learn those tricks about row number, rank, and dense rank, which we'll talk about more in the deep dive to accompany this episode. Learn about those kind of risky operations, the ways around them, and the ways that your company likes to work around them, and how that works within your business, and just take caution around certain operations and understand how that's affecting the infrastructure that you're building on top of. And then once you have that, everything else is pretty much fair game, but know how to not balloon your cost in a very avoidable way on those operations.
There's two more things that we wanted to make sure we mentioned too before we close out and move into our finishing up. So I think we put this in our secret sauce section. But what would you speak to with these two different terms that we have here?
Yeah, absolutely. We want to talk a little bit about how people can dive deeper into their query engine and understand which actual query processes are good and beneficial and reproducible, and which ones to avoid. And then also understand why. Because I think a lot of school is how, and a lot of depth is knowing why. So the first concept is idempotency, and this is something you might have come across. The simplest way to explain it is if I run the same process the same way, I should always get the same output. And this is like, think of like a function in math. Like if my function is +2, then any number, if I add 2, I should always get the same thing back. And there should be no variability, no edge cases, no weird things I need to handle. And basically what you want to do as a data person, scientist, analyst, whatever, is make as many processes as idempotent as possible. Leave no room for error, leave no room for guesses. And I think we want to give a concrete example here that we'll touch on more in the notebook deep dive for this episode, which is different table building operations. So there are typically two ways that we build tables of large data when we're querying in SQL. And one of them is insert data into table. The other one is create table as, or something similar. So when you insert data into a table, you have to create a table separately and say like, okay, my table is going to have column A, B, C. Now here's a bunch of data that fits that schema. And I'm just going to keep adding that data and appending that data, essentially. You can think of like the tables just getting longer and bigger the more stuff you add. The problem is, what happens if I accidentally run this function again? And imagine that this function is like encapsulating all this logic. So it's going to insert a bunch of stuff. Well, now my table's twice the size. Now my table's 3 times the size. And it's the same data being duplicated. But I might not be expecting that, because I might think that if I run it, I'll just get the same thing every time. And this is where idempotency comes in, because it's a silent failure where you don't understand that you're doing the wrong thing. There's no error. There's nothing to tell you that it's wrong. So you need to design your systems to use that create table statement instead of that insert into table statement, because that create table statement is idempotent. It's going to be the same every single time. Whereas if I just keep inserting and inserting, my cost, my storage, my duplicates are just going to keep going up without me even realizing, unless I actively check for that. So if you can get into the habit, and this is something I wish I did more of early in my career, if you can get into the habit of like never use insert unless you absolutely have to, always use create table, and just building these good practices, then you're going to just avoid a ton of pitfalls. If you accidentally rerun something, now everything's changed. So that's idempotency. And then the other one is query plans, which is basically understanding under the hood how your SQL is going to pull information for you. And I think I'll give the spotlight to you, Sam, to tell us more about this one.
Explain query is interesting. I'm working with one of my clients right now, and they want to learn a little bit more, teacher engineers a little bit more about the explain queries, and specifically in Snowflake. I think query plans are really important. So in Snowflake, you would run explain and then you would run a query. It would be exactly how you see the query plan, but they're really interesting and they took me a while. I started reading them in Spark, like probably 2021 was when I started reading through query plans in Spark. And it definitely took me a while to start making English of all of it. But you read in Spark, you read from inside out. In Snowflake, you read from bottom up, right? And the query plan is really to show you the order of operations about around what's happening. And that's how you understand, like how I mentioned earlier, how the filter is the last thing that happens. I learned that from reading the query plan, right? I saw like all these operations happened, 10 billion rows pass through. And then in my very last step, I just see 5. And it's because limit was the last thing that happened in the query plan, and you learn like there's like better ways to do this because the limit is the last thing that happens, right? Or if you have partition keys and then you run a where, like you notice that that'll be one of the first thing that happens. If you run your filter on the partition key, you notice that's one of the first thing that happens. You pull through such a small amount of data into the rest of your operations. I mean, assuming comparatively it's a small amount of data to the table size, that because it happens at the beginning, because that's a partition key, you define the filter on that partition key, it ran quickly, it got rid of a lot of the data, like you did what you needed to do, right? So I think that the explain and then running the query, which I believe would also be possible in Databricks, like very important to just seeing like, is this query a good idea to run? Or what could I look for? And at this point, you could take the explain, take the output of it, and then give it to an AI and just be like, what do you think about the query operation here? Maybe, and then I don't know, saying I'm working in Snowflake, and here's the output of the explain. What would you recommend? And like seeing what it gives. And I think that may be a good way to learn about how some of these things work and the impact of them. And then you can work faster and better and write better queries, right, as you move forward.
Yeah, I love that. And another thing that I started doing probably like a year and a half ago is trying to write the way that explain statements work. So when Sam talks about order of operations, I think what he's talking about is what we call order of execution. Of like you can write a query pretty much any way you want, but SQL is always going to put certain keywords first. So for example, the first thing that the SQL looks at is the from statement. So most queries follow a format of like select something from something else. And the first thing that the query engine is going to do is look for the from something else and say, okay, what table am I starting from? So like something I started doing is I started writing the from clause first. So I start with, select blank from the table, then I filter the table, I look at any partitions I need to use on the table, and then I go up and I select whatever I need from that option. If you can start thinking like a query engine, the more you can do that, the easier this will be. Because what happens is instead of like writing your query, doing another iteration to optimize, putting it into ChatGPT, optimizing again, if you can do that in like one iteration and get it pretty much done, you're just going to work so much faster. So like, again, the more you can just kind of align your brain with these processes and how the computer works, the easier it will be for you to work with the computer.
You become a machine.
Yes, you become the machine that you thought you were fighting with.
So we're about to hit the hour mark, whether we split this episode or not. But I know at least on this one recording, we're about to hit the hour mark. So I think we'll go ahead and wrap it up. But just remember, we do have a notebook. We do have kind of supplementary material to go along with everything that we've talked about today. And we'll do our best to make sure that a lot of the concepts that we've covered today and a lot of things we've talked about will be covered in that notebook. And then also then covered in the subsequent deep dive section. Even though we did talk for an hour, it feels like a deep dive. This is not the deep dive section. The deep dive section is going to be more hands-on and code forward, which will be me talking on that one, which we'll get to talk about UV and Marimo like we talked about last week. We get to talk about those a little bit more in depth in the SQL hands-on session here.
Yeah, you can always go deeper. You can always dive in to see something in action. And we'll see you in the next one.
All right. Thanks for your time.